We're going to look at the 7 times table. The first thing we're going to do is jot down our ones. Some of these, as you know, are going to be super duper easy. You know anything times 1 or 1 times anything is its own self is 7. 2 times 7, 14, double, right? That's easy. It's a nice easy way that we can remember that one. 3 times 7, we can double and add another 7 to get 21. It's a 3 times table trick from way back. 4 times 7, we can double the double, can't we? So double 7 is 14, double that, 28. We did 4 times table the other day, so you may even remember it from that.
It's really hot in here.
Then, 5 times 7, we can use a 5 times table. You might remember the answer is 35. 6 times 7, that's one of our favourites from the 6 times table that we did last week. Can anyone remember 6 times 7?
42.
42. It's the Douglas Adams number, isn't it? 42. Nice one. And as we remember, we can say 6 times 7 or 7 times 6 and get the same answer. They're reversible when we're multiplying. One of the more interesting ones in the 7 times table is 7 times 7, which is 49. It looks like it doesn't belong in a times table to me, 49. So how does that fit? But it's 7 times 7. 8 times 7, this is another class favourite. So you remember the pattern, 5, 6, 7, 8? So the answer is going to be 56, exactly right. What do I mean by that? Hopefully there's enough room on my screen to show it here. There is, yes. If I write 5, 6, 7, 8 like that, I can say 56 equals 7 times 8, or I can go 56 divided by 7 is 8. And it's the same family effect I can use, 5, 6, 7, 8. It means that 7 times 8 is 56. It's quite a handy little trick that you can use for your 7 times table and your 8 times table. It's pretty cool. When you're doing 9 times 7, I prefer to use the 9 times table trick. Now, when we get to the 9 times table, you'll see this anyway, but it's really handy. If you hold up your fingers and hold down your, 7th finger, so 5, 6, 7, hold that down, that gives you the answer in 10s and 1s, doesn't it? So you've got, how many there? 6 10s and 3 1s. So the answer must be 63. Well done, you guys. You're onto it this morning. 63. 10 times 7 is super easy. You don't even have to think about it, really, do you?
Replace the one with the number in front of the 0.
You've got it. Jackson, that's perfect. Yeah, 7 times 10 is 70. It's like 7 times 1, but the place value has changed. It's 10 times more. This one also easy. 77, you got it. And this one does confuse people when they say it by themselves, or by itself. They say 7 times 12. It's so hard. But it isn't really. Think about it as 10 times 7, which is 70, right? Plus 2 times 7, which is 14. So gives you 70 plus 14, 84.
84.
So it doesn't have to be hard at all. Good stuff, guys. We'll just pour this for a second. Okay, so what would happen if you got a bit stuck? It happens all the time. It falls out of your head. Say it's one of those meaner ones like 6 times 7. Looks a bit like this on the board. What strategies could we use to help us if we get a bit stuck? Now, the nice thing about the 7s is that it is made up of 2 times tables that you know really, really well. You know your 5 times tables really well. You know your 2 times tables really well. And you'll notice that 5 plus 2 equals 7, right? You've seen that before? Yeah? Okay, so if you are stuck, I can split this into 6 times 5 and 6 times 2. And add those together. By splitting it up, I'm still going to get the same answer, aren't I? Now, you could use this for the 6 times table or the 7 times table if it was that one. It works out the same. So 6 times 5 is
30.
30. 6 times 2 is 12.
Wow.
And that's an easy addition to get those together.
Yep, already got it.
The answer is 42, right? Now, this is a strategy that you can use even with other ones that you're a bit more unfamiliar with. By splitting it into 5s and 2s, you can work out even trickier ones. Let's have a try with that. So jot that down in your book before we carry on, and we'll do another one. Let's have a look. Okay, say we had one that you were a bit unfamiliar with. Say it was 13 times 7. We could use that strategy. There's two ways we could split this actually. We could split our 7 into 5 and 2, or we could split the 13 into 10 and 3. Either way would work. But for the sake of this exercise, we'll split the 7. 7 is made of 5 and 2. 13 times 5, you probably remember from the 5 times table we touched on this. Does anyone remember the answer?
65.
65, thank you, Finn. 65. Good. And then we can double 13, can't we? And that's easy. 26. Somebody said it perfectly. And then we can add those together to get our 13 times 7. So 6 and 5 is 11. You remember how to do these algorithms, right? Carry the 10 up with the other 10s. You've basically got 6 plus 3, which gives you 91. Who got 91 already? Nice one. Good. Could I have done it the other way? Could I have split it and split the 13 instead? Absolutely. In that case, it would have been 10 times 7 plus 3 times 7. So plus 20, plus 21. And I'll get the same answer, right? So there's two ways to do it. The strategy is the same though. It's splitting one of the numbers into easier things so that you can figure it out. And that's a really handy thing you can do quite quickly if you get stuck. Alright. Have you seen that used before, guys? Okay, so this is our algorithm. Can anyone remember what the first thing we would do is? Yeah.
Times the 7 by the 2.
Times the 7 by the 2. We're taking little chunks, don't we? It's a kind of a part-whole strategy because we're doing one little bit at a time. 2 times 7 is
14.
14.
Put the 1 on the 9.
You got it exactly right, buddy. So the 4 goes down there, the 10 from the 14 goes up here. 7 times 9, who remembers? We did it just before.
63.
63. And then we add this guy here to get what? 63 plus 1? Perfect. Excellent. 4 down there, and the 10s, and the 6 goes up here. It's 64 10s actually, but the way we talk about it is just 64. 7 times 8, anyone remember? It's one of our favourites.
56.
Well done in the back corner there. 56, and then it's going to be 56 plus 6.
56.
56 plus 6, who can do that in their head?
62.
62, good. So 2 goes down there with the other hundreds. And then your 6, I'm going to add that later once we're done. 7 times 7.
49.
49 plus 6.
56.
49 plus 6.
55.
55. Well done, Jackson. Exactly right. Nice. So 7,892 times 7 gives us 55,244. Quite an interesting looking number. Nice one, guys. So I'll put one of these up for you, and you give it a go. See what you come up with. That's right. You can do it, Jackson. Okay. So have a go at this one. If you're doing this at home, take your time. Remember, do it one chunk at a time. I'll pause it here if you're watching a video and have a go. Come back to us in a minute. Our guys in class are going to have a go at this as well. Okay, folks, let's have a look at that answer. Thank you. Settling down. Thank you. Alright, so 4 times 7 is 20, 28, so the 8 goes down there and the 1's 2 up here. Can we have less chatting in the corner, please? Okay, 7 times 8, 56 plus 2, 58, so another 8 down there, 5 goes up there. 7 times 9, 63 plus 5, another 8, and the 6 goes there. 7 times 2, plus 6, 20, 0 goes there, 2 goes there. Nothing times 7, 0. Add the 2, 2. 7 times 5, 35. We don't have to add anything to that one. We can just put the 5 there and the 3 there. 35.
21.
7 times 3 is 21 plus
24.
plus 3 gives you 24. Total number 24,520,888. If you got that answer, you did really well. Well done, guys. Well done, team. Are there any other tricks you can try with your 7 times tables? Well, yes, there is. Here's a fairly unusual, groovy one. If you can remember this sequence of numbers, you can get all of your times tables. So you put in these numbers into this square like this. You go 0, 1, 2, another 2, 3, 4, 4, 5, 6. So it's not straightforward, but you get the idea. 2 2's and 2 4's basically is the thing you have to remember there. Then to get the other half of it, you just do your counting up kind of backwards, and it's a bit more straightforward. And these will give you your answers. 21, 42, 63, 14, 35, 54, then, oops, sorry, beg your pardon, 56. Those of you at home watching will have spotted my mistake there. 56, 07, 28 and 49. And you'll notice that those numbers are the ones that appear in the 7 times table. 7, 14, 21, 28, 35, 42, 49, 56 and 63 up to 9. So that's a handy little trick that might help you to remember your 7 times tables. It does require you to remember this little trick, so it's probably not for everyone, but it's another way of thinking about it. Here's another really important thing that you can use to get the most out of your 7 times table. Learning the tables is the first step, but once you've learned it, you've learned a whole bunch of other really, really valuable facts. And we played around with this in class a little bit. So take, for example, 3 lots of 7, 3 groups of 7, 3 times 7. We know the answer is 21, pretty straightforward. We also know then that 3 times 70 is 210, or 300 times 7 is 2,100, or even if there's more place value is higher in each one, you could say even 30 times 70. Just got to make sure you've got the right amount of zeros at the end of your question. It's still 21 something. You keep the same order, but these amount of zeros there don't change the maths, if you like. We know that 3 times 7 is 21. We're talking about hundreds in this case, or 2 sets of 10s, or 3 times 7 lots of 10. So knowing how the place value works is tremendously handy. It allows you to do quite big numbers straight away with only the basic facts that you learn from your 7 times table, 6 times, 8 times, whatever times tables. If you can attach the place value to it, you get a whole bunch of bonus facts for free. It's a really handy trick. Okay, so what happens if we want to play around with fractions as well, using our 7 times tables? Absolutely we can. At this stage, it's really more about the technique of how you play with those parts of numbers rather than your times tables. But they do help you to figure it out quickly. So what we're doing here is just saying, well, 2/5 of 7, and I've put a little of there to remind us that the times symbol can mean of. So what this means is that the number that we end up with is going to be less than 7, even though we're multiplying by 7. Okay, so 2 7s is 14, we know that, and we don't multiply that because that's showing us how many times the thing that we're talking about has been chopped up. So we end up with this improper fraction, 14/5. And then all we have to do is say, well, how many times does 5 fit into 14? Well, it fits in 2 times with 4 left over. So 2/5 of 7 is 2 4/5. Now it's kind of a crazy thing to think about, but it's just another way to make your 7 times table a bit useful to you. You can do other things with decimals too, and we'll have a play with that in a second. Okay, so say you get presented with a question like this. It seems really tricky on the surface of it because we've got to multiply this number by a decimal number, 0.7. It's not even a whole 1. But we have some clues to start with. We know that the number that we end up with is going to be less than 629. In fact, it's going to be, in this case, 70% of it. Remember, when we're dealing with a number that is less than 1, we can say times is the same as of. But the process for working out the answer is pretty much the same. What I would do, before you do anything else, is put your decimal point in there, Dennis the decimal, as we often like to call them, and it helps us keep track of our place value. From there on in, it's just your times tables. 7 times 9, 63. 3 goes there, so we're going to have a 0.3. And then the 6 would go up there. 7 times 2 is 14, plus the 6 is a 0, because 20, sorry, is a 0. Nothing to, and then the 2 goes over there. 6 times 7 is 42, plus 2, 44. Should be 440.3, you get there. Now it seems very strange because you go, well, how can I multiply a number as big as that and end up with something smaller? But it makes sense if you go through it step by step. Now the tricky thing that I found there was remembering to stagger it down a bit. So like the answer to this one went across to here instead of going straight onto the top of that one up there, because we had actually multiplied there first. So it's kind of like you're working sideways a little bit, but it's just so we get the place value in the right place. If you're unsure, you can check it on a calculator, but I find it's more fun to do this sort of thing for yourself. Okay, have a go. This one's a little bit simpler in that there's only 2 digits to multiply by. It's 0.7. Pause it here, have a crack, and I'll come back to you in a second and see what you came up with. How'd you go? Well, step by step, 7 times 7 is 49, and 9 goes there, don't forget the decimal, and 4 goes there. We'll remember because we started with that one, we're sort of going across like that. 7 times 8 is 56, plus 4 would give us 60. Again, the answer is smaller than the number that we started with because we're multiplying it by less than 1. So 0.7 of 87 is 60.9. Now here's an important trick that you can do. I talked a little bit before, I said that is the same as 70%. And that's a handy trick. What is 70% of 87? In fact, it is 60.9. So it is a handy way if you're doing a test or you need to figure out a percentage. If you can understand what that is in relation to your percentage, then you're sweet. Percentage just means that it's out of 100, right? So you could imagine extra zeros on here if you wanted. It looks more like 70% there. So In fact, you can throw zeros all around here if it helps you to figure it out. 87.0 times 0.7 might make more sense to you. Just handy dandy tricks that you can do with any times table. We just happen to be playing with sevens right now.